Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, we are tackling question number 7 from the May-June 2024 Physical Sciences Paper 2 examination. Please do expect a total number of 9 videos since the question paper has 9 questions in total. So that simply means each and every question will have its own video. And please note that guys, knowing how to tackle exam questions is very important. I strongly believe it will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as well. We are told that a standard solution is prepared by dissolving 10 grams of sodium carbonate in a 0.7 in a 0.7 cubic decimeters of water. Okay, they want us to calculate the concentration of the solution. Concentration is equal to the mass all over molar mass multiplied by volume. Let's find the relative atomic mass number for sodium carbonate. Okay, for sodium the molar mass is 23, but I have 2 of the sodiums there, and then plus carbon, that's 12, and then oxygen, I simply have 16 multiplied by 3. Let's see what we'll get. 23 times 2 plus 12 plus 16 times 3. This will give us 106 grams per mole, né? Okay, so for us to find the concentration, we'll simply find our mass. Actually, we're given the mass, né? That's 10 grams all over 106 multiplied by the volume, which is 0.7. So this will basically give me the concentration. That's 10 divided by 106 multiplied by 0.7. So this will simply give me a 0.13 mole per cubic decimeters. So that's the concentration of my solution. Okay, and now I'm being asked, will the pH of the solution be greater than or less than 7? This is a base, guys, né? And the pH of a base is always greater than 7. Always greater than 7. Excuse me. They want us to write down the equation that explains the answer. Okay, let's take our carbonate ion and ionize them in water, né? We have CO3 2 minus plus water. So this will simply give us HCO3 with a minus plus OH over there. So on our product, guys, we simply have OH ions in excess. So whenever we have OH ions in excess, it simply means that the solution will be alkaline, or it will be basic. Are you together? It wouldn't be acidic, but it will be basic. Are you together? So that's why the pH is just greater than 7. Okay, and then now we are told that the sodium carbonate solution is titrated with dilute hydrochloric acid. The following indicators are available for this reaction. Okay, they are taking sodium carbonate, which is a weak base, and they are reacting it with a strong acid. Are you together? So the correct indicator over here will be indicator P. Why? Because the solution will be acidic since you are mixing a strong acid and a weak base. Which one of the following indicators, P, Q, or R, is most suitable for the titration? We just answered that, né? It's indicator P, and then the reason for that is because you are mixing a weak base and a strong acid. Okay, and then now we are being told that 0.1 moles of dilute hydrochloric acid is mixed with 0.024 moles of potassium hydroxide. The total volume of the final solution is 0.2 cubic decimeters. Okay, we are given a balanced equation. The first question we are asked is what is meant by a dilute acid? A dilute acid, guys, is an acid that has the least numbers, the smallest number of moles compared to the volume of the acid itself, or rather the volume of water just to prepare the acid. Ne? You must have the smaller number of moles and a greater volume of water, and hence you'll have a dilute acid. Okay, and then now they want us to calculate the pH of the solution. They are mixing a strong acid and a strong base together. So the substance that will determine the pH will be the reagent in excess together. If our KOH is in excess, that means our pH must be greater than 7, and if our H2SO4 is in excess, that means our pH should be less than 7, because the entire solution will be acidic. Okay, so before we find the pH, guys, we must simply find the reagent in excess as well as the limiting reagent. Okay, I know that I need 2 moles of my potassium hydroxide to produce 1 mole of H2SO4. Are you together? Okay, now I want to know if ever I have 0.01 mole of H2SO4, how many moles of potassium hydroxide will I need? I'll just cross multiply over there. 1 multiplied by X will simply give me X. 2 multiplied by 0.01, this will just give me 0.02. So remember that, guys, X just represents the number of moles of potassium hydroxide I will need. Are we together? But remember that, guys, I was already given 0.24 moles of my potassium hydroxide, but I only need 0.2 moles of my potassium hydroxide to completely neutralize my acid. Are we together? That means I will have some moles of my potassium hydroxide in excess. Okay, let's find the number of moles of the potassium hydroxide in excess. This will simply be the number of moles initial minus the number of moles that were used to neutralize the acid. Initially I had 0.024, but I only need to use 0.02. So the final answer will simply be 0.004 moles. So these are the number of moles of my potassium hydroxide that will be in excess. Are you together? The potassium hydroxide will be in excess because I only need a fraction of it to neutralize this entire amount of acid. Okay. After finding the moles in excess, I can simply go and find the number of moles of my hydroxide ions in excess. Ne? Remember that, guys, whenever KOH ionizes, we'll end up having potassium as well as potassium plus as well as the hydroxide ions. Ne? So I know that the number of moles of my hydroxide ion will be equal to the number of moles of my potassium hydroxide that are in excess. That's just 0.004 moles. Are we together? Why are they equal? Because the ratio is just 1 is to 1. Now I do know the number of moles of my hydroxide ion in excess. I can therefore find the concentration of my hydroxide ion. Ne? Concentration is basically number of moles all over the volume. That's 0.004 all over the volume. They said the entire volume is just 0.2 cubic decimeters. So 0.004 divided by 0.2. This will simply give me a concentration of 0.02 mole per cubic decimeter. Yes, guys, you can, after finding the concentration of this, you can go and find the concentration of your hydronium ion by using the constant ionization of water. Are you together? But I prefer going the POH route, ne? Because it's less mathematics. So POH is equal to log of the concentration of the hydroxide ions. This will be negative log of 0.02, and then this will simply give me negative log of 0.02. This will just give me 1.698. That's basically 1.7. That's my pOH, but I was never asked to find a pOH. Nah? I'm looking for a pH. So therefore, the pH plus pOH must be always equal to 14. Always. So I don't know pH, but I know that this guy over here is 1.7. That's 14. Therefore, pH is just 14 minus 1.7. I'll simply get a total answer of 12.3. That's how, guys, I were to find my pH. Now, let's remind ourselves what happened over there. Remember that, guys, they gave us a strong base and a strong acid, né? And we were never told which one of the two is in excess and which one of the two is the limiting reagent. And please note that, guys, whenever you titrate two substances, the reagent in excess is the one that will determine your pH always the time. Are we together? So over here we have our potassium hydroxide and sulfuric acid. Are we together? And then what I did here was to calculate my limiting reagent and the reagent in excess. I wanted to figure out that if I want to produce this amount of dilute sulfuric acid, how many moles of potassium hydroxide will I need? Then I found out that I only need 0.02 moles. But remember, initially I was given 0.024. That means my potassium hydroxide is in excess. Why? Because I need less of what I have to completely neutralize the acid. Are we together? So after establishing that my potassium hydroxide is in excess, I went and calculated, okay, that's number one. Then second step, I calculated the number of moles in excess of my potassium hydroxide. After finding the number of moles in excess for potassium hydroxide, I then found the number of moles in excess for my hydroxide ion. And then step number 4, I went to calculate the concentration of my hydroxide ion. Step number 5, calculated the pOH. And then after finding pOH, I then calculated the pH. These steps, guys, are always the same, especially if ever your base is in excess. You always do the same thing, guys. Every time, guys, if ever you're given a titration reaction, please do note that the steps are the same. Firstly, establish your limiting reagent. Secondly, calculate the amount of moles in excess. Thirdly, find the ions in excess. Then number 4, find the concentration of your ions in excess. Number 5, if you are dealing with an acid, you must go straight and calculate your pH. But since in this case our base was in excess, we had to calculate the pOH first, and then we found our acid, the pH rather, of our solution. So these steps, guys, are very repetitive. You will see like that all these 8 marks question in acids and bases, you just keep on doing in day 1 over and over and over again. But yeah, guys, so just stay tuned and wait for more videos. Dank.